Thank you very much, Phil. So LENScience is a science school community collaboration, and what I want to talk about is the potential for that kind of partnership to actually help New Zealand move forward. And the way we need to help New Zealand move forward is by generating a scientifically literate community to address some of these massive 21st century socio-scientific issues that we deal with. Whoops, and the thing is not quite what I expected. Okay, so we facilitate connections, and it does two things to our partners. It supports science education, and it enables communication and translation. And all the way through, I hope what you will hear from me is about partnership. It's not about science doing something for someone else. It's about science and education working together. And that's one of the ways where we are a little different. Okay, we reach more than 200 secondary schools in New Zealand. There's 500 all up. If we had an advertising budget, I wonder what we could achieve. 108 of those have high Māori or Pacific populations, or both. 96 of them are outside of Auckland, so those of you who are familiar with our Auckland-based programs, we do also have e-learning programs which are reaching fairly extensively. Now, a very conservative estimate is that over the last 5 years we've reached 40,000 students. We don't have a big flash website where people can log in and we can understand who's connecting, and we have one program in particular which is slightly viral, which we know is being used all over the country, so that 40,000 doesn't count in any of the students that are a part of that. So we're reaching fairly widely for a young program. We evolved out of the National Research Centre for Growth and Development and the Liggins Institute, and of course the NRCGD is a centre of research excellence that has connections in science in universities throughout New Zealand, and also of course with AgResearch and Landcorp. So our reach has also been extensive into other cores and throughout all the universities. Now, I particularly like this statement that Sir Peter made back last year. The process of science is not complete until the community for whom the knowledge has relevance are able to connect with the knowledge and decide for themselves how to use it in their context. And I think that says it fairly strongly. And that community, in our case, we're working with science where the community is the general community. You might be an engineer and you might be working with science where the community is the community of practicing engineers. But I'm talking about the general community in this case. And the kinds of issues that they need to connect with are everything from climate change through to the use of biomedical technologies. And this young couple are going to make decisions about how that science is used by themselves and in our society as they participate as citizens. So scientific literacy has a whole bunch of definitions, but broadly what it means is that you are able to use scientific knowledge and skills to make decisions in your everyday life at an individual, a family, and a community and a society level. And that's central to what our science education is about in New Zealand now and actually around the world. So probably when you went to school, the one down here, concepts of science, was what was drummed into you. Now, school science is about scientific literacy, which is a combination of all these things. Yes, we're still teaching some concepts, but it's also about understanding the nature of science as a knowledge system. It's about processes of science. It's about engaging with the culture of science, which is very important if you're going to actually use science in your life. And most importantly, the OECD now measure students' attitudes to science when they do the worldwide testing of scientific literacy, which, by the way, New Zealand sits very highly in. So it's about partnerships. So scientists and science educators working together are developing learning resources which can be used in schools. Again, partnership. The school is going to be the group that actually takes that out to the community. The school will adapt that to their setting, and there's a whole bunch of different programs that we're using. But what's essential is that the contexts that we're using need to be of relevance to each of the partners, the school, the scientists, and the students. All of them need to see the context, the science that we're talking about, as being something that matters. Now, a lot of our work is around NCD risk, which does matter to the NRCGD and the Liggins Institute terribly, but also to society and to kids, especially when they're from families where there's a lot of NCDs happening and affecting their livelihoods. And the United Nations have even come out and said that school partnerships are a really important part of the strategy to actually address non-communicable disease risk. So, to sum up what we're doing, we need to say, is the scientific evidence ready for community engagement? Is it relevant to the community? If it is, bring in our case, pedagogical design expertise to create the resources which will allow a school science partnership to form. The school will do the connecting to the community for you. They have the expertise. Through that community engagement, which the science community are a part of, there will be application of knowledge and improved health and well-being. So from modules of work that are used in schools that tell the stories of scientists, through to interactive e-learning events where the kids can actually engage with scientists, through to what we in education call LEOTC events, learning experiences outside the classroom, and many of you here might have participated in that. We have 5,000 young Aucklanders a year that come through our LEOTC program. We have a whole lot of different programs that are bringing the science community and the school community together to engage the wider society. Just to give you a few snapshots of the results that is bringing. First of all, knowledge uptake and changing attitudes and perceptions about science and scientists, and about the science that we're engaging with. Behaviour change about how we respond to science, how we engage with science as young people, but also about, in the case of non-communicable diseases, the decisions that our young people are making in their lives which will affect their non-communicable disease risk. And most importantly, the young people become the communicators of science within their families and within society. So we get this cycle happening. So it's not just from the scientist's perspective, and hopefully the scientist is also engaging in the communication and learning about things from the young people's perspective. To give you an idea of some of the solid data that you can see, this is sustained behaviour change in a group of students that we've been studying since 2010, who pre-intervention showed that their behaviours around diet and activity left them at high risk of non-communicable disease later in life. And we've got sustained behaviour change as a result of the program through to 12 months, and we're just exploring the 24-month data at the moment. So, effective partnerships mean that the school and the science community are equally important. They're key organisations. They've got to be pedagogically sound. That's a horrible word to some people, but that means that you've got to bring in those people called the pedagogues, the educators. They need to be a partner. You need to allow the students to enable authentic contexts that are of value to everybody. It's got to be part of the full program at school. It can't be an added extra. And there has to be teacher involvement in terms of professional development about pedagogy and about the science and about behaviour change as well. And most importantly, it's got to support the students to participate as communicators. So these are some of the key things that we've discovered are really important in these partnerships. We haven't gone unnoticed. LifeLab at the University of Southampton is a copy of what we're doing, and they collaborate with us. And we're just starting a combined research program to explore the effects of the program in New Zealand and the UK. Robert Winston has taken our ideas and broadened it into the physical sciences through particularly the LEOTC, the learning experiences outside the classroom aspects of what we do at what is now called the Reach Out Lab at Imperial College. Smart Life Lab is taking a very version of it and exploring that in Dublin. And we're currently working on some pre-feasibility scoping with Tonga and the Cook Islands to see how this kind of program can also be used in our Pacific region where there is a lot of work to be done. So I'd like to acknowledge many of the scientists at Auckland University and throughout New Zealand that have participated in this experiment, which is proving to be fairly good. And of course, thank you also to our funders. Thank you very much.